Hello and welcome back. As episode 1 gave us an AI reply, great for chat but could be terrible for a product. Let's say if you ask a model for some information and it might wrap the JSON in a paragraph, rename your field or invent some keys your front end never asked for. Today we force the model to return a valid type JSON every single time. Last episode, LLM was a remote function. We make a post HTTP request and get output as a text. This episode, we keep the same API call, but the reply must match a schema so our code can trust. While a free text is fine when a human reads it, your React app needs a contract. If the model returns the poetry instead of component of type, label, variant, the UI will crash. So we define the shape in Python with Pydantic, same idea as Zod or a TypeScript interface. Then we hand that shape to the OpenAI and say, fill this, nothing else. For this episode, we will only add one dependency, which is Pydantic. So let's go ahead and install the Pydantic. Once this is done, let's add a new file, same HTTPX style as episode 1 plus Pydantic. So let's go and start with this. We are going to have same .env load and async client again. We also have now base model as field for the schema, literal logs allowed values, and also list of arrays of components, and load the environment in the beginning. First, we define our front-end component schema. It is like a Zod schema or TypeScript interface for JavaScript engineers. Then we add a new class UI component. In that, we add or provide a configuration called extra equals to forbid. And what exactly that means? That means unknown keys are rejected. The model can't invent foobar or anything special. It has to stick to what we provide to it. And second, component type. We literally said like provide only button, input, card or heading. The description helps the model pick correctly. Then we'll have a label, which is what the user actually sees, and the variant logged to your design system tags. And finally, we will be having a width as a Tailwind class string to keep it simple for the demo. Next, let's add a new class UI layout with a base model. In this, we create this as a parent layout, a title plus an ordered list of UI components, which is going to be having like the nested models. This is how the real UI tree looks in a JSON. These both classes, think of them as a TypeScript interface. Your frontend already wishes it had. Next, let's set up our AI generator logic. We are going to have a same endpoint and bearer token as the episode 1. We are not switching the APIs. We are only upgrading the contract. Next, we'll create a payload. We use that to pass the Pydantic schema structure directly into the OpenAI's response format. The payload requires 4 things: model, messages, response format, and the temperature. We use the same model GPT-4o mini. The messages are going to be of 2 types: system and user. A system message sets the role, and the user message is the product asked. Still a normal chat completion so far. And this is going to be the magical part where we force OpenAPI to use the Pydantic schema, which is our response format. We pass UI layout.modelJSON schema to schema, where Pydantic generates the OpenAI schema for us and make it strict. Means stick to the schema. We pass temperature to 0.2, so it becomes less creative and more obedient to the structure. Next, we are writing the async client, which we already did in the episode 1. A post as usual. Content is still a string, but now it generates the JSON matching to the schema guaranteed. And we also remember that we need to get the content out of the choices and the messages. And this path is fixed that we need to use it always. So we get the raw content as I explained, and from the raw content, using the JSON.loads, we are going to get the structured JSON that we returns out of it. In case if there is an error, we returns the error as a response. Once we do that, now it's time to write the entry point, the main function. The simple ask is we are going to have a login form with heading, emails, password, and a blue submit button. We are going to have the print pretty JSON coming as a response, same async IO endpoint as in episode 1. Now we are done with that. Let's go and try run this. So I type the command to run the prompt builder file, and as you can see, I get the response. If we take a look at the close look all the component that we have received, we got the heading, that's your page title. We got the input for email, input for password, and button with primary. That's the blue submit we asked for. Frontend doesn't pass English. It maps component type to a component and passes label, variant, fixed width, and props one to one. No markdown fences, no sure, here is your form. That's the contract head. Run it again and the shape stays stable. That's what strict you. So we can say the schema is the contract between your AI and your app. Promoting alone is not enough. It should constrain the output. So this is what episode 1 and 2. In the next episode, we are going to look how does the search find the meaning, not just the keyword. Well, embed text into vectors and score them with cosine similarity. No vector database yet, just the math you can see. I'm going to tag the repository and the run command are in the description. See you in the next episode. Thank you.